So in example 5, f of x, y, z equals k times this stands for the position vector here of a particle in the vector field divided by the magnitude cubed. So first of all, I need you guys to understand this is just fancy notation for this vector field. F equals, okay, let's use, most students are really comfortable with component form. So let's use K times, all right, let's think about this. R could be considered just a position vector, x I plus y j plus z k. All right, so if we look at this component by component, the first component is going to be x divided by the magnitude of r cubed. But isn't the magnitude of r cubed just the square root? Well, actually it'd be 3.5, so let's do it using a power. Wouldn't it just be, if you think of the magnitude of r, isn't it x squared plus y squared plus z squared to the 1/2? To the third power, wouldn't that be a 3/2 exponent? So couldn't we write the denominator here as x squared plus y squared plus z squared to the 3/2? Oh, we're not there yet. Hold that thought. What's the numbers? Oh, this is all going to be posted for you. I'm sorry. So what are you talking about, the vector field, or you got it? Oh, well, we don't have that yet. We don't have that yet. We're not given those. We're going to come up with those. Okay. So now the second component, it's going to look the same, except it'll have a y on top. So I could actually make it k times y. I could have made this one k times x on top. And then divided by x squared plus y squared plus z squared to the 3/2. And then the third component of the vector field would be k times z over x squared plus y squared plus z squared to the 3/2. Okay? Do you guys believe that? So this is just a shorthand notation. This k divided by magnitude r cubed times r is just a shorthand notation for this vector field. Any issues there? Any questions? And then we want to find the work done by the vector field from the point. The initial point would be 1, 0, 0. The terminal point would be 2, 0, 0. But there is no curve specified. And as we're going to talk about in a little bit, the curve's not going to matter here. The value of this integral is going to be independent of path. Okay? So what's the simplest quote-unquote curve from 1, 0, 0 to 2, 0, 0? A line. A straight line. So this is where we're going to come up with those limits of integration you were asking about. So, okay, what would be, remember, this goes back, this chapter puts together everything you've learned about so far in Calc 3. This goes back to the very first chapter. How do you parameterize, that's what we need to do, we need to parameterize this straight line from 1, 0, 0 to 2, 0, 0. What two things do we need to find the parametric equations of a line? Well, we need, as opposed to a slope, we need a direction vector, right? So we, okay, so how can we get a direction vector? We take the tip and subtract the tail, right? So that would be 2 minus 1 is 1, and then the rest of the components are 0, right? So this could be your direction vector v. And then you need a point. Well, we've got 2 points on the line. You need 1 point. We'll just use the one in front here. So what are your parametric equations of this line? So line given by x equals something, y equals something, z equals something. What are the somethings? So most of them are 0, right? We have what? The 1, remember it's like x naught plus at, so 1 plus t, right? And then y is y naught plus bt, if the components of the direction vector are a, b, and c, that is. But that's just 0, right, on both. So y equals 0 and z equals 0 for the parametric equations. Now, here's to answer what I think was your question then, what would t have to run from so that the initial point is 1, 0, 0 and the terminal point is 2, 0, 0? T runs from 0 to 1. Or if you like, now you could go right from here if you wanted to. You could go right from here to the differential form, similar, and set up an integral similar to what we had in the very last problem. Come on. Sometimes my scroll bar disappears on this. I still haven't figured out what the logic in that is. I usually. Huh. Let's do this. Okay. But let's not do differential form here. Just for variety's sake, let's use this calculation formula. The integral f dot dr. That's kind of a useless formula other than saying, hey, find the line integral with respect to the vector field, right? So, and in this case, when f is a force field, this represents work. So the actual calculation formula is given when you parameterize it in terms of t, everything in terms of t, and you get f dot r prime of t dt. Let's use this formula just for the sake of variety. It helps to see a few of these examples, that is. So we don't have f in terms of t, but that'll be easy enough to get. What would r prime of t be if you think of r prime then using the parameterization form? Well, r of t would be just 1 plus t and then 0 and 0, right? What would r prime of t be? R prime of t would be just 1, 0, 0, yeah. Right? And then if you want, you could write down what f is in terms of t separately, if that helps. So and in fact, it might even be helpful to line it up with the thing you're going to dot it with. So what would f be in terms of just t? Using the fact that you know what x is in terms of t, you know what y is in terms of t, you know what z is in terms of t. What happens to these components over here? They zero out, right? You get 1 in the denominator and 0 in the numerator. They zero out. So it just becomes what? Just, okay, what is this? X is, okay, so k times 1 plus t over just, well, it's 1 plus t, right? X is 1 plus t. So 1 plus t squared to the 3 halves, which would be exactly what you said. Right? 0, 0. But let me write down the simplified form of that. Actually, that's not even the simplified form, is it? What's the simplified form? Yeah. So here, I'll do this, just so the notes are fairly complete. It would be k over 1 plus t squared. I've got an errant mark here that I didn't erase, so let me do that. And then 0, 0. Okay, is that clear what I did? Now's a good time to ask questions. Yeah?
I don't know if you already went over it, but for x, why did you make it 1 plus t rather than just making x equal t and then your limits being from 1 and 2?
Did Jay talk about, I'm sure he's talked about how parameterizations are not unique, right? This was just using, I came up with this parameterization based on the parametric equations of a line that you learned about, the formula for the parametric equations of the line in space that you learned about way back in the very first chapter. But parameterizations are not unique, are they? And in this particular case, having the extra +1 isn't going to make it any harder, really. But yeah, no, there are other parameterizations that would work, and you'll get exactly the same answer if you do it right. That's always the caveat, right? Okay, you guys. So, what do we need to do? We need to, according to this formula, we need to take what? The dot product of this version of f, right? And r prime. And you get a very easy to work with formula, don't you? So what do you get when you take f dot r prime? F dot r prime is just, k over 1 plus t quantity squared.
I'm sorry, were you trying to cancel the top, 1 plus t? Is that what-
So are you talking about right here?
Yeah. from-
So that with one of those leaves you with 2.
Oh, that was 3?
It was a 3, yeah. Is that okay? Any other questions? No. Okay. What's that? What's that?
Just do a brat.
Oh, okay. All right. Setting up the integral then, work becomes the integral. Now, the limits of integration in our parameterization went from 0 to 1, right? In a different parameterization, you'd have different limits of integration. But you should get the same answer if you do it right. Okay, and then I'll put the k. Is it okay if I put the k on the outside? Okay. All right. So we get this, right? The integral k times the integral from 0 to 2 of 1 over 1 plus t quantity squared dt.
2, 0, 1.
0 to 1. Why did I put 2 down? Was that your parameterization, 0 to 2? Is that where I got that from? Oh. Yeah, no, it should be from 0 to 1. It should be whatever this says, right? Okay. Okay. So we integrate, easy enough to integrate, right? So what do you get when you integrate this? You'll have a k on the outside. It's going to be negative, right? 1 over 1 plus t evaluated from 0 to 1, which is what? Yeah, you plug in this one for the upper limit of integration, you get 1 over 1 plus 1, which is 1/2, minus 1, which is, inside it's negative 1/2, but you have a negative outside, so it's, what, k over 2? K times 1/2? There you go.